All right, next up we're going to look at 12, 13, and 14. In order to do these, there's a few things you need to know about exponents and logarithms. So let's just review properties of exponents really quickly. So some properties of exponents, if I have the product of two things with the same base, like a to the x times a to the y, I add those exponents together. So that's kind of what's going on here in A. So to multiply these, you would just add the exponents. There's some adding fractions in there, but it's really not bad. The next property of exponents is if I'm dividing two things with the same base, we subtract the exponents. So a to the x divided by a to the y would be a to the power of x minus y. And then finally, the third property of exponents, if I have something like a to the x to the y, a power to a power, we multiply those exponents. So that would be a to the power xy. So that's kind of what's going on in C here. You're going to multiply the fractions there. Now, these properties also work in reverse. If I have something that is a number to a power that is a sum, I could split that apart into the product of two things with the same base. So we're actually going to use that property here in part E. We're going to use this the other way around. And we can use these properties in reverse really anytime we need to. So in F, we're going to use this property in reverse. We have e to a power that is a product of 3 in the natural log of x. We're going to split that product apart. So we can use those properties of exponents in both directions. The other thing we need to know is basically what a natural log is. So natural log of a number, that's what this ln stands for, natural log. That really just means, in this case, like natural log of 1/2, that's asking us e to what power equals that number. So e is just a number that is like 2.86, blah, blah, blah. It goes on forever. It's just a number kind of like pi. It's not important what it is, it's a number. So natural log is asking e, the number e, to what power equals that thing. So you're working with exponents there still when we're talking about a natural log. So all that being said, let's look at some of these problems. Hopefully A, B, and C weren't too bad. We were just working with exponents of numbers and variables there. It's when we get into D through I here that there's a few things we'll probably need to clear up. So in part D, the e to the power of the natural log of 3. Well, the cool thing about e and natural log is that they are inverses of each other. So anytime we see them together, they're actually going to cancel each other out. So in this problem, e to the power natural log of 3, that's just equal to 3 because e and natural log are inverses. They wipe each other out. So that one's pretty easy. Part E is a little more complicated here because we have e to the power 1 plus natural log of x. So because it's not just e and natural log, we can't just cancel those out and make this like 1 plus x. This exponent is more than just a natural log. So we're actually going to need to split that up, exactly like I showed you with those properties of exponents. So since I have an exponent that is a sum, I could write that as e to the first times e to the power of natural log of x. Because think about that property of exponents. We are multiplying two things with the same base. We would just add the exponents. So if we were combining this, it would turn into that. Which that makes this a lot easier to simplify then, because e to the first, anything to the first power is just itself. And e to the natural log of x, just like in part D, now e and natural log will cancel each other out. So it's just e times x, or ex. In part F, we have e to the power 3 natural log of x. So again, there's more going on in the exponent than just the natural log. So we can't start canceling things yet. We need to split it up. So we're going to use that power property of exponents. This exponent is a product of two different things, 3 and natural log of x. So if I have a power that is a product, I can write that as like e to the power natural log of x cubed. Because now if I did a power to a power, I would multiply those and it would be the same as this. Well, now I do just have e to the natural log of x, so those cancel out. This is left with just x to the third power. Is our answer there. So there's D, E, and F. And then G, H, and I all involve natural logs. So we'll just use a few properties of logarithms here, which are actually the same properties of exponents, just written a little bit differently. So the natural log of 1/2. Well, there's a property of logarithms that tells us how to deal with a logarithm of a quotient. It's the same way we deal with a quotient of exponents. We subtract. So the natural log of 1/2 could actually be rewritten as the natural log of 1 minus the natural log of 2. Because it's the same as with exponents. If I have a to the x over a to the y, I just subtract the exponents. It's the same with logarithms. If I have a logarithm of a quotient, I can rewrite it as logarithm of the numerator minus log of the denominator. Well, now this is a little easier to deal with because natural log of 1, remember what natural log is really asking. It's saying e to what power would equal 1? Well, anything to the 0 power equals 1, so that question mark would have to be 0. So the natural log of 1 is actually just 0. And then minus the natural log of 2, and then that would just equal negative natural log of 2. Would be our answer for part G here. I'm going to do H off to the other side in a different color, just so we don't get it mixed up. For part H, the natural log of the square root of e, there's a little bit of a trick we can do here. We can rewrite the square root. Instead of using a radical, I'm going to write that as the natural log of e to the 1/2 power. So instead of a square root, I just used a fraction exponent. And what do we have here? Natural log and e right next to each other. That cancels out, and this is really just equal to what's left, 1/2. And then lastly, in part I, the natural log of 1 over e to the x, that kind of combines the last few problems. Just like we did in G, if I have natural log of a quotient, I'm going to split that up. Natural log of 1 minus the natural log of e to the x. What is the natural log of 1? Well, just like we said up here, that is 0. And the natural log of e to the x, well, natural log and e just cancel each other out. So that leaves us with just 0 minus x, or negative x. So there's parts D through I in problem 12. We're going to use kind of similar methods in problem 13 and 14 to solve for a specific variable. So let me get some stuff out of the way here. And switch colors again. In number 13, if I'm trying to solve for y, that just means get y by itself. So y is kind of trapped inside this natural log. It's really important that we understand that doesn't mean like natural log times y, and we can't just divide by natural log, because natural log isn't like a number. You can't divide by it. It's an operation. That would kind of be like trying to divide by square root or something. It doesn't really work that way. So natural log is an operation. Well, how do we get rid of an operation in an equation? If I gave you like 3y equals 2t minus 3, the operation happening to y is multiplication. You would undo it with division because that's its inverse. It's the same thing here. We have to know what is the inverse of a natural log, and it's what we were doing up here. The inverse of a natural log is e to the power of something. So if I want to get rid of this natural log, the trick is to do what's called exponentiate both sides. I'm going to basically just turn both sides of this equation into exponents. So I'm going to write this as e to the power of natural log of y equals e to the power of 2t minus 3. Because remember from Algebra 1 way back when, you can do anything to an equation as long as you do it to both sides. So my operation I'm doing to both sides here is just making them both powers of e. When we do that, e and natural log cancel each other out, and that gives us y by itself, which is exactly what we wanted. And once y is by itself, we don't need to go any farther. It asked us to solve for y. We did. So y equals e to the power of 2t minus 3. On 14, solve for k. Well, we've got e to the power of 3k equals 5. How do we cancel out e? We use its inverse, natural log. So this time we're going to take the natural log of both sides. So the natural log of e to the 3k equals the natural log of 5. Well, natural log and e will cancel each other out, leaving us 3k equals natural log of 5. Divide both sides by 3 to get k by itself. So k equals the natural log of 5 over 3. So there we go. There's the exponents and logarithms section worked out for you.